Like with notes number 3, now we have notes number 4 with perpendicular, bisector, and altitude, and we will still be solving, but now with these two types of special segments. Remember, first when we see a picture, we need to determine which type of special segment it is, so we know what characteristics we need to pay attention to. In this very first one, it tells us that ZX is the perpendicular bisector. The perpendicular part is already drawn for us in the picture, but the bisector tells us that our two segments are going to be congruent to each other, so WX and XY. If they're asking us then for the measure of angle YXZ, we know that's going to be 90 degrees because it is the perpendicular bisector. Then if WY, so that's this whole distance, is 24, we know that since these two pieces are congruent, that those both are going to be 12, so WX will be 12. If WX is 6, so now they're making kind of a new problem. So I just drew out a new triangle here for this one versus the 12 is using that original one. If we know that WX is 6, the other piece will be the same, and WY then is asking what is the whole length, and that would be 12. For number 4, we need to look at this next triangle, to the triangle ABC, and we need to determine what type of special segments these three lines are in our figure. We can see that they're 90 degrees, but if I extend it up, it does not go through the vertex, so it's not the altitude, but it's going to be the perpendicular bisector. That means it also goes through at the midpoint on each of those sides. So I'm going to draw some congruent lines in there so that we can remember that when we find our measurements. If it says that XA, so this dotted line right here is 8, then they want to know what is the length of XC. Well, with perpendicular bisectors, if we connect that point where they all cross in the center, I remember that point is called the circumcenter, that if we connect that to the vertices on our triangle, the length of all three of those dotted lines are all going to be the same. So all of those are 8. So when they ask us what's the length of XC, it will also be 8. If they give us that AB, so this outside distance is 20, remember that means that both of these are 10. When they want to know what is BE, that's just the 10 because it's only one of the pieces. If XA, and again, if I see XA is used again, so they're changing up my answer. So if I'm going to redraw my triangle so we can look at that instead. So XA is like those pink lines, so it's my purple ones in this new figure. If that's 8, I know the rest are going to be 8, which we already saw before. But now they want to know if XF is 5, they want us to find this one. But if you notice, this is a right triangle that is drawn. And the only way to find the third side in the right triangle is if we use Pythagorean theorem. So I know the 8 is my C, the A could be my 5, and then the B can be the FC. So given the equation, I want you now to go through and find out what is FC going to equal. For your final answer, this is what you should have gotten, would be the square root of 39, which is 6.24 for the length of FC, so on the outside of that triangle. Just like before, we need to determine which type of special segments we have now for this new triangle. So triangle VWX, and we see that they're 90 degrees and they go through the vertex. 90 degrees goes through the vertex, 90 degrees go through the vertex. So that is the altitude. If we need to name two congruent angles in our vertex, the only ones we know for sure are going to be any of these that are 90 degrees. So it could be on either side of our altitude. The first one I have is angle XZW. Next we could do the exact other side, so VZW. If we wanted to name these two pairs of angles, we could have XYV. Then for the other side would be WYV. For the last two you could have chosen would be WUX. Lastly then would be VW, or VUX, sorry. So this next one is just knowing that it's the altitude, so if we want VY X, that's this angle right there, and that's 90 degrees since it is the altitude. We have another triangle down here for number 11, so triangle ABC, and AD is the altitude, so that means that it's going to be 90 degrees on both sides. We have two right triangles in there, and then they give us that the angle of ABD is 48 degrees, and we need to find the measure of angle BAD. So that's right there. Now remember, this is an altitude, so it's 90 degrees, and we have all three angles need to add up to equal 180. When we add our 48 and 90 together and then subtract it from 180 degrees, we are left with 42 degrees. In number 10, we have our triangle ACB, and AD is the altitude, and we already found that this is 42 degrees then. So if we need to classify the triangle ACB by its angles, we need to know all three angles. Well, we have the 48, we don't know what this one is, and we do not know what this other piece is, so we know what the full angle is going to be. So on this one, I'm going to change it to triangle ACD instead. So we're just going to find this side. But the one part we do know is this 90 degrees in that triangle, so because you have one angle that's 90 degrees, it's going to be a right triangle. In number 11, we're still using the same original triangle, so I'm just going to redraw it since it's a nicer version. And if we know that AD is the altitude, that tells us these are 90 degrees. We need to figure out which of these statements are true if AD is the altitude. So angle ABD, that'd be this angle right there, it says is 90 degrees. So we know that is not true. So I'm going to put a little X there. Next, we have an angle ADC. So remember, the D is the vertex. So now this one right here is 90 degrees. So that one is true. Then it has BD is equal to CD. Well, if it's just the altitude, those do not need to be equal to each other. Only if it is the perpendicular bisector, or if we have median, that's where it's going to go through at the midpoint. But altitude does not need to be equal on each of those. Triangle ABD, is that a right triangle? Yes, because we have one that is 90 degrees right there. So there are two that are true, and that's letter B and D.